Hey calculus class, this is a video about an intersection between a line and a plane in C3 and C4. So we've got three potential things that could happen. So between our plane and our line, the line could go right through the plane and it would intersect at one point. So we'd be looking for a point of intersection that's like X, Y, Z, right there. And then they could be parallel, so the plane and the line could be parallel to each other, which would mean they would have the same direction vectors, those would be parallel, or the normal vector of the plane would be perpendicular to the direction vector of the line, and there would be no intersection points. Or the third case is the line lies directly on the plane. So there's like an infinite number of intersection points. Infinite solutions. Okay, so those are the three possibilities. So let's do an example. Okay, so there's a line, which I'm representing with L. We've got it in vector form. So this is the point on our line, and this is our direction vector. And then here's the plane. And we know from the plane that the normal vector of the plane would be 4 to -1. Just in case you wanted to know that. So before we start, you don't have to do this, but if you wanted to just check, hey, are these guys going to intersect? I'm curious. You could compare your direction vector of your line to your normal vector of your plane. So if this is our line and this is our plane's normal vector, we know if they're parallel or coincident, then those two things are going to be at 90 degrees to each other. So we could just do the dot product between M and M, I would think. And if the dot product equals 0, then we know our lines are perpendicular to each other. Okay, so let's just do that. So 4 times 1 plus -4 times 2 plus -8 times -1 equals 4 minus 8 plus 8, which equals 4. So they're not perpendicular to each other, so therefore they're going to intersect. Okay, so since we know they're going to intersect, we want to merge the two equations together to find out when they're equal, to find out when their x, y, and z coordinates are the same. So I'm going to turn my line into parametric form. So I'm going to create a parametric equation, x equals 3 plus s, y equals 1 minus 4s, and z equals 2 minus 8s. And then I'm going to take my parametric equations, and for all of these, so if x equals 3 plus s, I'm going to sub it into my plane. And then y equals 1 minus 4s, I'm going to sub in for y. And z equals 2 minus 8s, I'm going to sub in for z. So let's do that. So we've got 4 bracket 3 plus s plus 2 bracket 1 minus 4s minus z, which is 2 minus 8s. Minus 8 equals 0. So we just replaced x, y, and z with our parametric equations. And I'm just going to expand them using the distributive properties. So 12 plus 4s plus 2 minus 8s minus 2 plus 8s minus 8 equals 0. And I'm just going to go through and collect all my like terms. So I've got 4, take away 8 is -4, plus 8 is 4 again. So I got 4s. And then I've got 12, 14, 12, 4. And then if I bring it to the other side, it's -4. So I just found out that s is equal to -1. So now I know what my s value is, so I can go back to my parametric equations and find out what my point of intersection is. So x equals 3 plus s is negative 1, so therefore x equals 2. Y equals 1 minus 4 times negative 1, so y equals 5. Z equals 2 minus 8s, which is negative 1, so that's 10. So my point of intersection, POI, is 2, 5, 10 between the line and the plane. Cool. Let's just quickly look at an example where they're not going to intersect and see what happens. Okay, so okay, let's say our plane is 2x minus 5y plus z minus 6 equals 0, and our line given in parametric form is x equals 2 plus t, y equals 2 plus 2t, and z equals 9 plus 8t. So there's our parametric and plane equations. Okay, so first if we want to see if they're going to intersect or not, we can test their vector. We can check out the normal vector and the direction vector. So our normal vector is 2, negative 5, 1. I got from those coefficients. And then our direction vector, I'm going to get from my parametric equations, just 1, 2, 8. So I'm going to do the dot product again and just see what happens when I take the dot product of those vectors. So 2 times 1 plus negative 5 times 2 plus 1 times 8. I'll just see if it equals 0. So 2 minus 10 plus 8 equals 0. So since I just showed that those vectors are equal to 0 when I do the dot product, that just shows you that if you had a plane, that's your normal vector. And your line, if your line was like this, then the direction vector of your line is going this way. So if they are perpendicular, like I just drew them to be perpendicular, then when we do the dot product of two perpendicular vectors is always 0. So since they're 0, we know they are perpendicular. So that's going to tell us that either they're parallel, or I guess our line could still lie on the plane. So if we want to test that out, so we're thinking could be parallel, but could also be coincident. So if we want to test that out, we could check, we could take a point and sub it into our plane. So let's see this parametric equation here. You know how I took 1, 2, and 8 as the direction vector? Well, I also know a point on my line is actually 2, 2, 9. So these numbers here give us a point on our line. So 2, 2, 9, if we had a line, 2, 2, 9 is a point on that line. So if I take my plane and I want to know, hey, is my line on my plane or is it parallel to my plane? So if this point is actually a point that's on the plane too, then they'll be coincident. But if this point right here is not in this plane, then they must be parallel. So I'm going to take my plane, 2x minus 5y plus z minus 6 equals 0. And I'm going to sub in my point 2, 2, 9. And I'm going to see if it's actually on the plane. So 2 times 2 minus 5 times 2 plus 9 minus 6. I'm just going to see if that actually equals 0. So 4 minus 10 plus 9 minus 6 is negative 12 plus 9, negative 3. Oops, and it's supposed to equal 0 because left side we want it to equal right side. So that does not equal 0. So therefore, the point 2, 2, 9 is not on our plane. And that means that the plane is parallel to the line. So parallel, both parallel because that point 229 is not on our plane. Cool. There was another way we could have done that, just saying. So this question right here, we got the plane and the line. You could have just solved it the same way we did before by subbing all the x's and y's into each other. So I'll just show you really quickly. Okay, hey, so I just had to pause my video because I'm totally recording this at parent-teacher night and someone came to talk to me. Haha, so I forgot what I was going to do. Ooh, I think I was going to show you another way to solve it. All right, so I was going to say, if you don't feel like doing dot product and like subbing a point in to see if it's parallel or coincident, you can just go for it and solve the question like we just did. So sub all these x values in for x, sub these y values in for y, etc. So let me just show you really quickly. So that would look like 2 times 2 plus t minus 5 times 2 plus 2t plus z. Oops. 2t plus z, which is 9 plus 8t minus 6 equals 0. Right? Verify that? Yeah. Okay, so you can sub x, y, z into your plane equation, and you'll end up with 4 plus 2t minus 10t plus 9 plus 8t minus 6 equals 0. And if you simplify that, you'll notice you get 2t minus 10 plus 8. So that leaves you with 0 t's. And that's going to equal 4 minus 10 plus 9 minus 6, which is negative 3. So this is an impossible situation here. So just seeing this, there's no value of t you can insert here that will make this equation equal negative 3. If you sub negative 3 in for t, it's going to equal 0. Everything you sub in for t will make the equation equal 0. So since there's no solution, that's telling you that the lines are parallel, because it's telling you there's no way you can find a point of intersection. So the lines must be parallel. And just to add a point to that, if you end up doing something like this and your answer is 0t equals 0 as your final answer, that kind of answer tells you that the plane and the line are coincident, because any value you put in for t will make this equation equal 0. So it's telling you there's an infinite number of points of intersection. So if you put a 4 in for t, it's going to equal 0. If you put a negative 7,000 in for t, it's going to equal 0. Okay, hope that helps.